Our next presentation comes from Harry Smith, Sales and Senior Research Engineer for Atmos International here in the UK, and recent winners of the prestigious Queen's Award for Enterprise Innovation. Harry will present leak and theft detection strategies, integrating established and innovative technologies, and include real-life leak and theft examples from around the world, how they happened, and how Atmos detected them. Take it away, Harry.
Thank you very much. I'll just share my screen and then we can begin the presentation. So hopefully everyone can see my screen, and thank you again for the introduction. So I'm Harry Smith and I'm from Atmos International, and I'm a sales and senior research engineer. And today I'm going to be talking about leak and theft detection strategies. So we're going to be looking at Atmos' established leak detection and theft detection methods, and we're going to be looking at the improvements that we've made to these technologies in the fight against better leak detection and better theft detection. So who are we? Well, Atmos International, we are a pipeline application company, and we've been in business for over 25 successful years, and we concentrate on three main areas. We work in leak and theft detection, we work on online and offline simulation, and we also work on a number of pipeline applications such as batch tracking and pig tracking, and we also work in aviation as well. We support more than 215 clients in 60 countries. We have a portfolio of 18 software and 10 hardware products. We have a dedicated team all around the world of 160 professionals, and that's growing all the time. And to date, we have our online systems on more than 1,500 pipelines around the world. And what we're very proud of is we continuously invest in our technology and in our research and development. Before I go on to the innovations that we've made, I want to talk about the two main leak detection methods that Atmos International offers. Now, the first one is what established our company and is called Atmos Pipe. Now, this is based on the flow balance method, and it takes data usually from the SCADA system. So we'll take in pressure, flow, and temperature readings, and we'll provide leak detection that way. Now, what's unique about Atmos Pipe is it uses a sequential probability ratio test. Now, what this allows us to do is provide a very reliable and robust system, because it is looking for all the key characteristics that a leak shows. And it can also track all the operational changes. Now, when the system is very confident that a leak is present, it will generate a leak alarm, and we can provide leak location, a flow rate, and we can output those alarms to your SCADA system, to an app, and we can even email you. It now has a new module called fast scanning that I'll go into a bit more detail later on, that allows us to improve leak location with a flow balance method. As I said, it can also monitor pressure during all operational conditions. So that's during dynamic, static, and during operational changes. And we've also included a rupture module as well, in line with API 1175. As well as Atmos Pipe, we have one of our latest technologies that we call Atmos Wave Flow. This combines two independent methods into the same software and hardware package. So it combines the negative pressure wave principle, or the rarefaction wave. So this detects the pressure signature from the onset of a leak or theft, and it can provide a very accurate leak location. We combine this with an intelligent flow balance so that we can detect small discriminaries in the flow. So this allows us to detect new leaks, existing leaks on the pipeline, and also slow forming leaks. Now, if we have the ability to put multiple pressure sensors along the line, which has been a key point in a lot of everyone's discussion, that the more sensors we can have on the pipeline, the more performance we can offer, then we can analyze all the data from all these inputs, and we can provide better sensitivity, response time, and leak location. Now, what Waveflow also uses is dynamic model analysis. So as I said in the previous slide, a leak and a theft has a very unique pattern in terms of what happens to the flow and pressure. And when the Atmos Wave system detects this change, it will alarm. So what this means is our response time can be very, very quick, which is obviously key when we're talking about theft and leaks, because we reduce the environmental impact and the potential fines that come with it. So what improvements have we made to our leak detection system? Well, firstly, we looked at the challenges that we're facing in leak detection and theft detection. A lot of pipelines are being kept in service much longer than they were built for. And we need to start retrofitting leak detection systems onto these lines. Now we face the following challenges: lack of communication, lack of power, lack of instrumentation in the right places to provide effective LDS, and even lack of housing in some respects. We also have the need for pre-existing leak detection systems to improve the sensitivity, response time, and leak location. Maybe it's a system in a country that started to suffer from theft. One of the first things we've recently developed is what we're calling the fast scanning module. I'm sure you're all aware that probably the most used leak detection method around the world is a flow balance system. And traditionally, this would take SCADA data at the refresh rate that the pipeline operator could give you. And maybe the best refresh rate was 1 second. Now, what usually would mean if we had a leak, the best leak location we could provide would be plus or minus a kilometer. What we've done with Atmos is we've combined hardware with our flow balance system found in our Atmos Pipe system and our Atmos Wave flow to dramatically improve the leak location we can provide. So we've now gone from plus or minus a kilometer to plus or minus 100 meters. And we do that in two ways. The first one is we will install our data acquisition units that we call an AWAS. That allows us to sample pressure data and flow data at a much higher acquisition rate, up to 60 samples a second. Or we can connect to SCADA systems that support historical reads, and we can request the data to be collected at a much higher sample rate. Now, what I want to do is give you an example of how this fast scanning module dramatically improved our theft location. So this pipeline is 56 kilometers long. It has multi-product going through it. It's a single inlet and outlet. It's based in Latin America, and it does suffer from theft. Now, our Atmos Pipe system alarmed, and it provided an improved leak location using this module of 9.280 kilometers. And the actual theft was found at 9.210. So that's a difference of plus 70 meters. But if we weren't using the fast scanning module and using the standard SCADA rate of 5 seconds, then the error would have been 2 kilometers. So you can see what happens when we combine a software solution with hardware solutions. As was mentioned in the introduction, we've recently been awarded the Innovation Award, the Queen's Award, for our negative pressure wave that we call the Atmos Wave. We have developed this over the years to be able to detect smaller leaks, but more recently we've been able to get it to detect more thefts and to improve its location, because location when we're dealing with theft is critical. We've also improved the communication and infrastructure of this technology to make it a more robust system. So we deal with much less false positives, and we're able to give operators far more confidence. Now, as well as improving our software, we've looked at the hardware we want to be able to offer to pipeline operators. Now, there was discussion at the start saying that investment needs to be put into sensors so that we can deploy more sensors on the pipeline, gather more readings, and then through more readings, we're able to get better performance. Well, at Atmos, we developed a hardware product that we call the Eclipse. Now, this is a complete non-intrusive piece of hardware that clamps onto the pipeline, and it's designed for rapid deployment. But what it gives us all the essential instrumentation we need to provide an effective leak detection system. So this unit has non-intrusive flow, non-intrusive pressure, and temperature, all built into one ATEX hardware with all the communication and processing that we need. So let me break down some of the features. It works on painted lines. It currently works on diameters from 4-inch to 24-inch. It will work currently only on liquid lines and chemical lines. As I said, it combines non-intrusive pressure, flow, and temperature. It has onboard processing built in, and it works on an array of communication methods. So we can get this to work with radio link, 4G, 3G, VPN, standard TCP/IP. And it also gives very good pressure. So we're able to detect very small changes in pressure down to around 10 to 15 millibar. So in some cases, our non-intrusive pressure sensor can still offer the same performance as an intrusive PT. And of course, it's ATEX certified Zone 1. But just a little brief development timeline of how we got to the Eclipse unit and what we're working on for the future. So as I said, we've developed our own acquisition unit. back in 2010 that we call the AWAS unit. This allowed us to start sampling data at a much higher acquisition rate, which allowed us to improve system performance such as sensitivity, response time, leak location. In 2016, we started to notice that in some scenarios, we're not able to install an intrusive PT where required. So we developed our first non-intrusive pressure that we called the Atmos Halo. And you can see an image of it here. In 2018, we decided to combine the benefits of the AWAS unit with the Atmos Halo and combine it with non-intrusive flow and temperature. We built in an array of communication options. We also made sure it could work with solar power and wind. And we made sure it worked with all the Atmos LDS systems. So it will be able to work with our Atmos Wave flow and as well as the Atmos Pipe. So what are planned for 2020 and onwards? Well, we want to continue to improve the non-intrusive pressure, try and get more performance out of it. We have over 90 of these Eclipse units purchased and being installed around the world, the UK, the USA, Singapore, and Belgium, just to name a few. We're adapting it for the water industry. We recently got it certified, so to try and prevent it being tampered by thieves, this device can now be buried to a depth of 2 meters. And we're also working on larger versions, so we're working on a 48-inch version of this unit. I want to show you here is a project in the UK. So this was a turnkey solution we were asked to be provided by a pipeline operator in the UK. So we have 2 non-intrusive Eclipse units, and we're utilizing 4G VPN to send the data to our LDS servers where the data is processed. And if any alarms are found, it's then outputted to the customer's SCADA and emailed to them. But at one of their locations, power wasn't an option. So what we have done is installed solar and wind, which now powers the device. If there is any issue with the solar panel or wind, there's batteries in the cabinet, and it will run for 14 days on the batteries. So this is an example of utilizing all the options available on the Eclipse unit. As well as showing you the hardware and what we can deliver, I wanted to show you the data that the units provide. Let's start with the screenshot to our right. So what we're actually looking at here is 2 Eclipse units. So the black is the inlet of the section and the pink is the outlet of the section. And this is during a leak trial by the customer. Now, what we're looking at in these red boxes is the pressure drop associated with the leak event opening. And we're able to detect that very small change in pressure and provide a leak location. What I want to show you here is this is a standard startup on a pipeline. And again, this is 2 non-intrusive Eclipse units. And as you can see here, we have flow data coming in, and we also have non-intrusive pressure data. But what you're noticing here is we can clearly display the types of operations that you expect, and we can show the level of detail that you usually expect to see with intrusive instrumentation. Here is a leak test that was done with an Eclipse unit in Belgium. Now, what was interesting about this section, it was around 30 kilometers long. At the inlet of this section was a non-intrusive Eclipse unit, and at the outlet of this section, there was an intrusive PT. The customer did a number of different leak sizes. The flow rate of this line was around 300 meters cubed. And what I'm showing you here is a screenshot of a 1% leak and a 0.6% leak. And as you can see here, we're seeing a distinct drop in both scenarios. Now, at the start, we all had a very interesting debate on theft detection and how thieves are always trying to change their tactics. They're trying to steal at much smaller flow rates. They might even put in smaller hole sizes between 2 and 4 millimeter. And what also we've noticed in theft detection is what they'll try and do is steal in running conditions and use the noise floor of the pipeline to mask their activity. So what Atmos has done is we developed a new software module that can bolt onto our wave flow system that we call Nanowave. Now, what this requires is distributed sensors along the pipeline. Depending on the length, we'd require one every 3 kilometers, 20, 30 kilometers. And it dramatically improves our sensitivity during dynamic conditions. If we can space the number of sensors correctly, we can detect down to 0.04% of the nominal flow. So this allows us to detect very small theft in running conditions. It also means when we're talking about leak detection that we can detect weeps. What it's also we found that we can utilize this configuration for is for multi-phase pipelines as well. If we can have a number of distributed sensors along a pipeline, we can also provide effective multi-phase LDS, which is also another challenging pipeline scenario. So while we're talking about theft, what have Atmos's successes been around the world? Well, as everyone has said, theft is a global problem. And as you can see, Atmos has been able to provide solutions globally. And more importantly, we've been able to detect and locate numerous theft events. In the UK, during 2014 to 2018, there was a number of theft events. Our system was deployed onto a number of operators, and we've seen a dramatic reduction. And at the moment, our systems seem to be acting like a deterrent. But as we were saying, this has been combined with a number of methods as well. There's been new laws in place, additional security put in place. So it's about combining different solutions. The same has happened in Indonesia. So they invested in Atmos technology and installed the Atmos Wave flow solution alongside changing legislation, additional security, and other technology. And they were able to dramatically reduce their theft problem from 700 taps in 2013 to less than 10 in 2018. Now, what you probably have noticed as well, in Costa Rica, the number's very high. So 785 tapping points have been detected and located since 2017. The good news is, in 2020, we are starting to see a downwards trend. This has also been put in line because the pipeline company in Costa Rica has put in additional security. And one of the biggest changes in 2020 is new legislation has come through, making this more of a criminal offence, so that when the criminals are caught in the act, the punishment is much more severe. And we have started to deploy systems in India and Mexico, and we're starting to see events being detected there. Now, what I want to do is just show you a few examples, and I'm sure you all around the world have seen these different techniques, and this is the challenge that we face as a leak and theft detection vendor. But I wanted to talk about some recent events that have happened this year. This was a very interesting one. So we were contacted by a customer in India. They were aware of product loss on their pipeline, but they weren't able to find the tapping point. So Atmos deployed our equipment, installed it very, very quickly. And within 1 day of data, we were able to accurately locate this tapping point. What was more interesting is we only had data from one sensor at the time. So we analyzed the drop during static conditions, and using a technique that we call single sensor, we were able to provide a very accurate leak location, less than 6 meters. And what was very interesting about this pipeline is it actually had a fiber optic system installed, and it was unable to detect this tapping point. And as you can see here on the picture, this was once they uncovered it. But this pressure change when they opened this device to steal fuel was very, very small. We're talking about a 0.2 bar change of pressure. As well as this, I wanted to show you an example of the type of tapping points installed in the UK. So as you can see here, this blue dot indicates the tapping point, and we provided a location of around here. So we were about less than 30 meters from the actual tapping point. And what the thieves had done is run a 300-meter hydraulic hose to this abandoned yard. And what they were doing was driving a van or a truck over, bringing the hose through the bottom of the van, filling 1 or 2 IBCs, rehiding the hose, and then driving off. Finally, a few more examples of the different tapping points. And of course, as we're all aware, tapping points can fail. And this is what we're trying to mitigate. We're trying to reduce these ultimate failures. But thank you very much for listening. Again, I've been Harry Smith. If you would like to contact me, my email's here. If you'd like any more additional information, please visit our website. And I look forward to answering questions now. Thank you very much.
Thank you very much, Harry. Thanks for the overview and the case histories. Certainly quite some sophisticated theft.
Yes.
So we have a couple of questions that have come in. The first I want to ask is from Kent Wardley, who asks you to describe the process of installing Eclipse on buried pipelines.
On buried pipelines, so at the moment on buried pipelines, these have been installed inside valve pits. But we have developed the technology, so if the pipeline was excavated, we would install the device and then the ground could be put back over. However, in terms of maintenance, that's not ideal. So it's usually been put inside valve pits at the present time to prevent them from being tampered with.
Makes sense. There's a clarification coming from Gleb Klushnikov, who asks,
Yep.
Does Eclipse measure the value of the pressure or just the change in pressure?
Just the change in pressure. So when we talk about leak detection, obviously we're interested in seeing the changes associated when a leak or theft occurs. So we're not particularly interested in the actual value or the pressure in the line. What we're wanting to sense is those changes and provide an accurate leak location and a fast response time, and obviously reliably. So that's it. It's just measuring change.
Nice one, thank you. Great also to see the areas that you're planning to expand into, including in the water industry.
Yes.
Leakages are such a huge issue there, and fresh water is only going to become more scarce.
That's it.
Do you have any plans to expand into gas lines as well, or is there not seen to be as much?
No, we do work on gas lines. Currently, the non-intrusive technology is for liquid lines, but we do have plans to try and develop that type of technology for gas as well. Because, as we said, if it's non-intrusive, you don't have to turn off the pipeline. The pipeline can continue running. You might have to be careful if it's a multi-product line of what fuels in the line. So you might have to wait if it's diesel and jet going through. But it means there's less downtime. It's not a risk point either. The thieves can't suddenly turn an intrusive tapping point into a tapping point for themselves. So it's an exciting technology that we're looking forward to continually improving.
Perfect. In the interest of time, I'll just ask one more question.
Yeah, sure.
From Nikolaos Salmantanis, who asks, can you elaborate the various communication capabilities for the Eclipses?
Yes, so we can use 4G VPN, so utilize data SIM cards built in and send them over a secure encrypted connection. We can obviously utilize existing communication, so your standard TCP/IP IP addresses, and we can also do line of sight radio link. And from that, we seem to be able to cover most scenarios, considering that sometimes these devices have to go into remote locations. In the future, we might look at satellite communication as well, sending small packets of data from very remote locations.
Perfect. Thank you, Harry. Thank
you very much. Thank you for letting me present.
No problem. And congratulations again on the Queen's Award.
Thank you very much.